Welcome to the session on probability, calculating probabilities. The objectives for this session are to define an experiment, event and sample space, and calculate probabilities for events. So let's begin with the definitions. When we want to predict the chance of something happening, we use probability. An experiment is a process which can be repeated and gives rise to a number of outcomes. An event is a collection of one or more outcomes. The set of all possible outcomes is a sample space. So let's take a look at an example. An experiment could be tossing a coin 3 times. The set of outcomes for this experiment is that shown in the curly brackets here. So heads, 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 tails, and so on. An event E could be tossing exactly 2 tails. And there are 3 ways of that happening, which are highlighted as shown. So heads, tails, 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 heads, tails, or tails, tails, heads. And the probability of an event occurring is the number of ways of the event happening divided by the total number of outcomes, which in this case is 3 divided by 8. So 3 ways of tossing exactly 2 tails divided by a total of 8 outcomes. Let's now take a look at some important properties of probability. The value of the probability of an event is always between 0 and 1. So we can write this as 0 less than or equal to probability less than or equal to 1. If an event is impossible, the probability equals 0. If an event is certain, the probability equals 1. Probability can be written as a fraction or decimal. Let's now have a go at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. 2 fair dice are thrown and their sum is noted. Find the probability that the sum of the dice is equal to 7, this is part A, and for part B, that the probability is less than 7. So let's create this table. This gives the sum of all the possible outcomes. So for example, if we throw a 2 and a 3, we have a sum which is equal to 5, and that's written here as shown in the table. So if we solve part A, we're going to find the probability that the sum of the dice is equal to 7. All the 7s in the table have been highlighted. Notice that there are 6 of them. So the probability that the sum is 7 equals 6 out of 36, which is the total number of outcomes. And now for part B. Find the probability that the sum of the dice is less than 7. All of these have now been highlighted in red in the table. All these values are less than 7. And there are 15 of them. So the probability that the sum is less than 7 is 15 out of 36. And now for example 2. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a go at example 2a first. The table shows the mass in kilograms of 45 Rottweilers. One dog is selected at random. Find the probability that the dog has a mass of 55 kilograms or more. So let's solve this. We're looking for the probability that the Rottweiler's weight is 55 kilograms or more. This occurs in the last two categories of the table. There are 11 dogs in the 55 to 60 category and 7 dogs in the 60 to 65 category. So we add those two values together, 11 plus 7 as shown, and divide that by the total number of dogs altogether to give us 18 out of 45. And cancelling the 9s, top and bottom, gives us 2 over 5. And now for part B. Find the probability that the dog has a mass of less than 55 kg. So this time we're looking at the last three categories, and the last three categories have a frequency altogether of 6 plus 8 plus 13. And we divide that by the total number of dogs altogether. This gives us 27 out of 45. And of course we can cancel to give us 3 out of 5. This brings us to the end of this session. If you have understood its contents, you should be able to define an experiment, event, and sample space, and calculate probabilities for events. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.